I'm Rob Bell, and this is the Institution of Mechanical Engineers' top 5 tanks. 5 tanks and 5 rules for engineering success. By the end of 1914, there was deadlock on the Western Front. To break this stalemate, the Kaiser's generals turned to their chemists and developed poisoned gas. The British turned to their engineers. New problems requires new solutions, requires innovation. But just how do you innovate? Well, you think big, you act fast, and you start small. Our tank number 5 is Little Willie. The first ever tank, it stands example to how innovation should be carried out. You quickly build a prototype, you get it running, and you start to learn. The tank was the innovative combination of 4 existing technologies: armour, a gun in a turret, the internal combustion engine, and caterpillar tracks. Armour and guns in turrets were old technology, but lightweight, powerful engines and reliable caterpillar tracks were recent inventions. Walter Wilson and William Tritton brought these existing technologies together. Little Willie was their first prototype, a testbed, and they learnt many a lesson, particularly with the tracks. Existing tracks just weren't robust enough for such a heavy vehicle, and they'd sag away from the rollers when crossing a trench. Tritton developed his own stronger tracks to counter these issues. They also learnt that the bottom profile of the tracks needed to be curved to reduce the length of track in contact with the ground to make it easier to steer. Without Little Willie, it would have taken much longer to encounter these problems and find the innovative solutions to them. That's why Little Willie is our tank number 5. So, are all great products innovative? Well, the answer is no. And a good example of that is our number 4 tank, the Sherman. There's nothing innovative about it at all. It's just really, really, really well designed. So what do we mean by good design, and how do you create it? A good design takes into account everyone who'll use it, and I mean everyone. And in the case of the Sherman, that means the people who make the components, the people who put them together, the people who have to repair and maintain the tank, the people who have to lift it and lower it onto a ship or a train. And of course, it had to be designed for the people who'd work inside it, and for the operations it would carry out. So look here, just one example of how well the Sherman was designed. It was incredibly easy to change the transmission, easily accessible and unbolted from the front of the tank. How do you get good design? Communication. Designers have to talk and listen to all the people involved in the creation and operation of a product and try and find a way to balance any conflicting requirements. One variant of the Sherman was the Firefly, with its famous 17-pounder gun. It reminds us that whether you're designing a car, washing machine, or a tank, you're in an arms race, and that every new product needs to be designed to match future competition, not what's currently in the market. It also reminds us that sometimes design is about compromise. The turret on the Firefly became more cramped and difficult to work in, but that was deemed a worthwhile trade-off in order to have a more powerful gun. The design problems of fitting such a large gun into the Sherman turret were solved by one William Kilbourne. He reduced the height of the gun by turning it through 90 degrees so that the breech block now sat horizontal. And the 1 meter travel of the 17-pounder when it fired had to be reduced. He replaced the original recoil system with twin hydraulic cylinders, meaning that movement was reduced to just 25 centimeters. The cradle and barrel of the gun also had to be redesigned to ensure that it was properly supported. William Kilburn was a member of the Institution of Mechanical Engineers, or the IMechE. The IMechE has over 120,000 members and has been at the heart of mechanical engineering since 1847. Right, back to tanks. It's unusual for any product to go straight from the drawing board into production. A period of testing and development is needed to weed out any teething problems. Development is an engineering specialism in its own right, and it's crucial if you want a reliable product. Our tank number 3 is the Churchill. Now, it was rushed into production as there was a desperate need for new tanks, and it had many problems to start with. But one by one they were overcome, and through development it became a great tank, staying in service until the 1950s. The Churchill was heavily armoured with excellent mobility. It had the innovative Merritt-Brown triple differential transmission designed by Dr. Henry Merritt, another member of the IMechE. Instead of powering just one track and braking the other, this regenerative system provided power to both tracks during turning. The Churchill served in North Africa, in Italy, Northwest Europe, and on the Eastern Front, where it participated in the battles of Stalingrad and Kursk. It was also the basis for many special vehicles, including the famous Hobart's Funnies and the armoured recovery vehicle. These Churchill-based variants remind us that many engineers spend their career maintaining and operating equipment, thinking on their feet, diagnosing problems, and then coming up with solutions. Engineers are, by nature, curious. We like to get our hands on what the competition are making. Use it, test it, take it apart. How does it compare with your own products? Are there any ideas worth stealing? This exercise is called benchmarking, and our tank number 2, this Panzer III, was brought to the UK for that precise reason. So why is this our number 2 tank? Well, it's got some good design features. The extensive use of welding throughout gives the most armour for the least weight. But more important than its design features was its design process. Many contemporary British tanks weren't designed with an eye on the future. Wars see rapid change, and several designs of British tanks became obsolete because they couldn't be up-gunned or up-armoured. In contrast, the Panzer III was designed with growth in mind. First built with a 37mm gun, the turret was designed to take an as-yet non-existent 50mm gun. And it was this forward thinking in the design process that gave this tank its edge. So why isn't this brilliantly thought out Panzer III our number 1 tank? Well, a product may be innovative. It may be well designed and developed, but all of this is wasted if it doesn't get to market on time and if it's not available in the volume required. In the critical year of 1941, less than 1,700 Panzer III tanks were built, and less than 500 Panzer IVs left German factories. That was the year the Third Reich chose to invade the Soviet Union, and that same year, Russian factories produced 3,000 T-34s and 1,100 KV-1s. But in 1941, one country outbuilt even the Soviets. In that year, almost 5,000 tanks left the factories the length and breadth of Britain. Nowadays, the British tend to remember the war as David versus Goliath, the plucky underdog against the might of the Third Reich. They forget that British industry outproduced Germany in most types of weapon. During the crucial early years when the war could have been lost, Britain had the industrial capacity to send tanks to France, then to Egypt, Greece, and in October 1941 to the Soviet Union. This high output was achieved by bringing in new factories and new workforces that had never built tanks before. It was achieved by constantly improving processes and increasing efficiency. Our #1 tank is representative of that success. It was in service from the very first day of the war to the very last. The Matilda II. Designed at the Woolwich Arsenal in London and built in factories across the UK, the Matilda is a veteran of so many battles. In the desert, in the jungle, and in the snow. When it was introduced in 1939, it was one of the most heavily armoured tanks in the world, and its 2-pounder gun was capable of knocking out most opponents. The fate of the Third Reich was decided by its failure to defeat the Soviet Union before the end of 1941, and the Matilda played a part in that epic struggle. Britain sent Matilda and Valentine tanks to Russia to aid in the defence of Moscow. And like their British counterparts, the Russian tank crews appreciated the solid construction of the Matilda. And compared to the overworked tank commander of a T-34, who also had to double as a gunner, his comrade in the Matilda could focus on his task. He also had better vision and a radio too. The British used the Matilda on the front line until 1942, by which time its 40mm gun was no longer capable of destroying the latest enemy tanks. The Russians continued a little longer, but that wasn't the end of the Matilda's career. The Australian Army used it in jungle fighting on the Pacific Islands, right to the very end of the war. If a design satisfies the needs of a particular market, it can stay relevant and stay in service for a very long time. We're so lucky to have so much of our industrial heritage preserved. But seeing a tank like Matilda here, cold and still, just doesn't convey what it was like to operate it, or indeed what it was to face one in the midst of battle. Fortunately, this Matilda has been overhauled in the Tank Museum workshops. At special events here in Bovington, you can see it, hear it, smell it, feel the vibration in the ground as it goes past. You can appreciate it technically and emotionally, and perhaps understand why it's our #1 tank. That's the end of our IMEC Top 5 tanks. We hope you've learned something about what makes a great engineering product. If you want to find out more about an exciting career in engineering, click on the link below. And please subscribe to the Tank Museum YouTube channel and support them on Patreon. And perhaps you might think about becoming an engineer yourself. The world needs more engineers.